Hello and welcome everyone out there. In this video, I'm going to explain about the laws of refraction and the refractive index in a quick and easy way. So check it out till the end to clear concepts, and don't forget to subscribe, hitting the bell icon to get the latest updates every other weekend.
Yeah, yeah.
Have you ever wondered why does a pencil seems to be bent inside water? It happens due to a phenomenon called refraction, which can be explained by the laws of refraction and refractive index. Let's get to know why does it happen. Suppose it is a glass slab which is a denser medium and a bulb is there in the air which is the rarer medium. Rarer is lighter medium, means it has got lesser density compared to the other medium. Now suppose a ray of light is coming from the light source or the bulb at a speed of 3 into 10 to the power 8 meter per second, hitting at a point A. Now, if we draw a perpendicular to it, it will be called the normal. So, by definition, it is the perpendicular drawn to the surface of separation at the point of incidence, which is the point A here. Now, as the light ray is moving into a denser medium, its speed will be reduced to 2 into 10 to the power 8 meter per second. Due to the obstruction created by the denser medium, it will bend towards the normal. The phenomenon of changing the path of light due to different medium is known as refraction. Let's discuss the terms related to it. Incident ray, a ray which strikes the surface of separation of two optical medium. Refracted ray, a ray which travels in the second optical medium with a change of angle of the incident ray. If the light ray continues to move through the denser medium, it will hit the second surface of separation between the denser and rarer medium. As it is moving again into the rarer medium, its speed will increase to 3 into 10 to the power 8 meter per second. Due to that reason, it will again bend away from the normal and come out of the denser medium as emergent ray. Now we can clearly observe that light is being deviated from its path. This deviation is known as lateral displacement. It is the perpendicular distance between the emergent ray and the path of incident ray. Therefore, we can finally say that the change in the direction of the path of light when passing through different transparent medium is called refraction. Let's discuss the laws of refraction formulated by the Dutch scientist Snell. The first law states that the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. It means if you were to draw this on a piece of paper, they all will be on the same plane of paper, not out of the paper. Let's talk about the second law of refraction, which is popularly known as Snell's Law, which describes the refractive index denoted by the symbol mu. Now, look at the angle which incident ray makes with the normal is called angle of incidence, and angle of refraction is the angle which refracted ray makes with the normal at the point of incidence. Now, if the second medium is denser, angle of incidence will always be greater than angle of refraction. Let's draw a circle with any radius. Now let's draw a perpendicular EF from the intersection point of the circle and the incident ray on the normal, which is in the air, and another perpendicular GH on the normal, touching the intersection point of the circle and the refracted ray, which is in the glass or any other denser medium. Then the refractive index would be the ratio of these two perpendicular lines, that is EF upon GH. It is constant for a given pair of medium. Now, if we divide the numerator and denominator of this ratio by the constant value of the radius of the circle drawn here, we derive the ratio of the sin I upon sin R, which is also constant and equal to the refractive index. Snell's law can also be understood by the ratio of speed of light in the incident medium by the speed of light in the refractive medium. In simple words, if we consider two medium, that is air and the glass, the refractive index of the glass medium would be speed of light in the air or vacuum upon the speed of light in the medium. Let's discuss the last relation in details. We can relate mu, c and v from the following relation. We already know that refractive index mu is the ratio of speed of light in air or vacuum denoted by c upon the speed of light in the medium denoted by the v. This ratio is also known as absolute refractive index denoted by n. Therefore, using this relation, the refractive index of the glass would be the speed of light in air or vacuum upon the speed of light in the glass. Now, putting the values of the speed of light in air and the glass respectively, then after simplifying those values, we derive the refractive index of the glass is equal to 1.5. Refractive index has got no unit as it's a ratio. To find more about refractive index and Snell's law, please check out the end-screen videos and the description box.
At last, I have a small solicitation for you. If you find this video helpful or motivating even a little bit, then please subscribe this channel to support us. And share it right now with your friends or loved ones to motivate them as well. You can also leave your valuable comments about the topic of the next video you would like to watch, because our sole objective is to help you. That's it for now. We will be back with a new video every other weekend. Until then, keep learning, keep sparkling. Thanks for watching. Bye bye.